Hello, everybody. This is Professor Ma, and this is the introduction to the sections on log and exponential function, the review of that. Okay. And the functions that we are quite familiar with, formulas, are the exponential, so in the form b to the x. So, for examples, the basic formula to think is 2 to the x. Okay, and notice first things about it, this is quite different from the other formula of squaring x squared. So in particular, F10, the 10 becomes the exponents here, okay? Meaning that 10 twos multiplying, which you wind up with 1, 0, 2, 4. But on the other hand, the squaring, you're changing the base. When you're putting x equal to 10, they change the base, and with 2 10s multiplying, and it's only 100. So this is a polynomial, and this is the function we are talking about. Okay. And the graph y to 2 to the x looks like this if you chart a table. And in particular, if you make the base smaller than 1, so this is y equal to 2 to the x. The bigger the x becomes, the bigger the y becomes. But on the other hand, if the base I use is smaller than 1, it's like 1/2. The bigger the x becomes, the smaller the y becomes. It actually goes to 0. Okay, so that's why it tapers off, becomes 0. And these are the graphs, basically, of exponential formulas. And when we have an exponential formula, basically we are going forward. We're saying that in this case, 2 raised to a power 3, and the outcome is 8. This is the declaration of this sentence. And when we associate these 3 numbers, the base, the power, and the result in this format, as exponents, something raised to some power equal to something, we call this the exponential format of stating these relationships. There are other ways to state these relationships, okay? And then probably say, I mean, what do you mean other way to state this relationship? For instance, if I were to ask who is Homer, then the answer is Homer is Bart's dad, okay? If I were to ask a question, who's Bart? And then the answer is, Homer's kid, okay? These 2 sentences and answers give the same relationships, even though the focus are different, right? And the first question is who's Homer? And we'll focus on Homer. And the second one focuses on Bart, and so it's slightly different, but they have the same relationship. We have the same type of situation. We can restate things slightly differently. So if the question is, say, what was the power you need to get to 8? We call that answer, the power, to be the log of 8. Okay. In other words, this question is the same as asking, say, power needed to get 8. Okay, power needed to get 8, and then the answer, of course, I know what it is, 3. So we say log base 2 of 8 is equal to 3. Okay. In this way of formulating this relationship between 2 and 3 and 8, we call this the log form. Okay, and this log form right here is exactly the same relationship that's here except it's stated in the law. So, and in both relationships, when we deal with this type, one or the other form, what's the first things you look at in this relationship? You look at the base. Okay, always look at the base first. Okay, always, when I see log of something, I always say, what's a base? Same thing when you raise power or something, what's a base? And so remember that. And in particular, log of something cannot be, log of the domain of log function cannot be negative. Okay. So you cannot say as what's log -1 of something, 2 to the -1. You're asking 2 to what power is -1, and there's no answer, real answer for that. So, and here are some statements going from the exponential form into the log form. Okay. What's the first step? Write down what's the base. Log base what? If the base is 4, then we are dealing with log base 4. Okay. And bottom one, what's the base? The base is u, so we're dealing with log base u. Okay. So, and vice versa, we can write log form back to exponential form easily. And again, when you're looking at something like that, and when I look at something like that, so, well, what's the base first? The base is 3. Then write down 3. Then it raised to a power -2, give the 1/9. Here the base is v. Power is the 2w. It's whatever the log is, and that's supposed to give us a minus b. Okay. So this is how we go back and forth in exponential and log. Here's a table. If I make a table of log base 2 log, and so this is the graph. Notice there's nothing on the left-hand side because there's no negative x around to take log, or u in this case. And this is the log, depending on the basis pass, bigger than 1 or between 1 and 0. 2 equal ones. And 2 logs base we use most often, that's on your calculator or scientific calculator. One of them is base 10, that's the log log, and the other one is the ln, okay, it's base e. Okay, base 10 is called a common log, okay, and that's using sines, and because sines are metric base 10, that's why in science we use the common log. I mean, in metric systems, but in science, but in computations, turns out a lot of computations are a lot easier using base e. So log without writing the base is assumed to be base 10, and log e is written as ln. So that is 2 different forms. It's ln base e, log base 10. So, and here is using those 2 base log form, going back and forth between fill out one form of the others. So you can just scan through these. Okay. And what kind of question we can ask? Well, one of the things we can ask is, get x into one of the positions in the log expression and ask the students to rewrite it and drop the log. Except in this case, after you drop the log, you get an equation in x. Then you have to proceed to solve that equation. So, like for instance, drop this one, okay, which is the same as 1/9. Okay, and then x log 9, x base, now x is a base, so this will translate into the following. Okay, and then that's the equation x. You notice it's the equation x squared. Again, we will come to x squared equation, then you solve the equations. then you discard the numbers you cannot use. Okay. But finally, we have these rules concerning the log. How how the log breaks up products, okay, and divisions and power, okay, and you can read the verification of these. And where do we use these? And it turns out we use these to break up formula in calculus. So for example, here's the examples, okay? And so I call this disassemble, okay? So we use those rules to disassemble formulas. And how do we do that? So the first thing you want to do is you want to factor everything. Okay, and put everything into fractional exponents. Okay, what? Because now I can break up the products in the numerator as adding to logs. So, and the divisions as subtracting the log of the top and the bottom. And this bottom one, the square root is 1/2 power, and this 1/2 power can be extracted outside using the rules for power. And that's then you continue break it up, and this is as far as I can go in breaking up or disassemble this formula completely. Okay, the trick is to keep factoring into just factor completely. And finally, we have some basic equality of identity of logs. Okay, so I leave you think about this one and these. Okay, and also these ones. Okay, basically log and the base raise power to log undo the and each others. These, of course, is this problem, of course, because we have adding exponents, and so it becomes multiplication of individual ones, and then this part is 7. Okay, e to ln base e of 7 is that's going to give you 7. That's why I gave 7. And that's it. Okay. Bye-bye and have a good day.